Welcome everybody. I see we're filling up pretty quick here, so I think we can get started. Welcome to the info session for Kemi and Matt Tsai. My name's Professor Dave Flanagan. I'm the Director of Undergraduate Studies for the Material Science and Engineering program. And I'm going to go through here the MSc program, give you an overview of that, and then I'm going to hand it off to my colleague, Professor Kevin Dorfman. He's going to tell you about the chemical engineering side, and then we're going to end with a student panel and field your questions and give you some answers to those, okay? Okay, I think we can get started, so if you want to advance, yep. So I'll just give you a quick overview of the undergrad program here. I'm going to tell you about the courses you'll take, but even before that, I'm going to step back and tell you about what Matt Tsai is. And then we'll dig into how the curriculum is structured before ending with a little bit of discussion about research and then the resources that are available to you in the program. Next slide, please. Okay, so you may be wondering what material science is. Certainly you know what chemistry is, you know what physics is, and you certainly probably know what chemical engineering is, but you may not know what material science and engineering is. So material scientists and engineers, we do quite a bit. So we design, discover, and apply new materials to solve big problems. That's what we do. And at the core of this discipline is the idea that materials will drive new technologies and they'll provide critical solutions to a lot of the problems that we're facing. So this covers a wide range. This can be sustainability, it can be information, it can be renewable energy, it can be a whole host of things that we cover with the idea that materials are at the core of this. And so we cover, a wide range of real pressing current issues, right? That span a pretty broad spectrum. And you can kind of see these here listed just as some examples of the sectors that material scientists and engineers end up working in when they're done with the degree. And I think what's pretty interesting about the discipline itself is it's the first discipline, the first academic discipline that was formed through a fusion of some core disciplines, engineering, chemistry, and physics being those disciplines. And this occurred in the 60s and was really a call to develop new materials to answer a lot of the problems that we have. Next slide, please. What is the structure of our program? So we have the materials tetrahedron, that's what we follow. At the four corners of this tetrahedron are structure, properties, performance, and processing. And then in the center of this that binds this together in some ways is characterization. So the curriculum is built around this tetrahedron. And probably most notably, as you'll see coming up, we have labs that touch on all four corners of the tetrahedron. So we have a structure lab, properties, performance, and processing labs as well. You take 2 of those each year, 2 of the junior year and 2 in the senior year. And then interwoven again with all of this is characterization of materials. So learning different characterization techniques to characterize all different types of properties of the materials that you're interested in. Next slide, please. So how is the curriculum structured in a little bit more detail? So our core curriculum is centered around really 4 things. First, our materials fundamentals. So this will be thermodynamics, kinetics, electrical and magnetic properties. And then we have a numerical methods class that you'll take sophomore year. And that numerical methods for material science class will teach you ways of computing different materials problems. And then you'll carry that through the remainder of the program. Those tools that you learn in that class, you'll carry that through. So that's why we have you take it in the sophomore year, so you're armed with those tools. We also focus on different types of materials. These are metals and alloys, ceramics, polymers, and then composite materials, sort of tying all of those different materials together. And then, as I mentioned, the lab courses, we've got 4 lab courses that you'll take. And then you'll end with a senior design, a capstone. And there in the senior design, you will form teams and you will be paired up with an industry mentor. This will be someone from, say, Seagate or 3M, and they will have a real problem that the company has. They will bring that to you, And then your team will work on that problem. You'll cover all aspects from the technical side to the financial side. And so over that semester, you will learn how to basically devise a plan to solve the problem, come up with a solution, and then propose that solution. Okay, next slide, please. This is the 4-year plan. You can find this on our website, so I'm not going to dwell too long on this, but this is the map. It walks you through the courses that you'll take and when they will occur in the program. And so it's really spring semester of sophomore year where you start taking Math-Sci courses. So intro to the numerical methods, you'll be taking that. And you'll also be taking 3011 in the fall semester of the sophomore year. You can also take that in the spring, but and that's where you'll begin that. And then junior, senior year, you'll be focusing on all the key courses in the program. Next slide, please. So we have technical electives that are required for the degree. You need 13 credits, and we have a pretty massive list of courses that qualify for this. And so I'm not going to run through any of those, but you can find it in on our website again, the courses that we accept. We typically are pretty open to accepting courses that aren't on that list, so we're really flexible in that sense. The technical elective courses should be 3,000 or higher, with one exception. That's these computer science courses. Understanding how important coding is becoming in basically all aspects of science and engineering. So we do allow a 1,000 level comp sci course to count for that tech elective. And there's a number of other opportunities that you have to take these technical electives. Next slide, please. One important part of your experience as an undergraduate could be doing research. So if you're thinking about grad school, or if you're just interested in getting into the lab and learning some different techniques, you can pair up with a faculty member, join their group, and you can do research on some problems that they might have in the lab. And so the faculty in the building are pretty diverse. We cover a pretty broad range of topics. And so really there's going to be something that's gonna interest you. And so I just encourage you to go on the website and look through these different areas to get a sense of what's going on in the building. And then if you get interested, to reach out and inquire about available projects. Next slide, please. So why is it important to do that? It's important for grad school. It's really critical, actually, for graduate school. The admissions committee, wherever you apply to, will look to see if you've had research experience. In addition to that, of course, it enhances your education. You get to actually apply the things you're learning in the classroom in a real setting in the lab. And that's always, I think, really valuable for crystallizing the concepts and helping you sort of remember those in more of a long-term fashion. So we have how to do that here. You can just take a look at that. And then there are also additional resources beyond just the department. There's the Office of Undergraduate Research. There are year ops that you can do. We also will allow you to do research for credit. So you just talk to the Dougs to figure out how to do that. And then there are these National Science Foundation research experiences for undergraduates, where you will go to another institution for a summer and do research in someone's lab there. Those are great experiences as well. So just talk to Casey or me. Next slide, please. A number of other experiences that you can do that probably aren't too surprising, but internships, many opportunities for internships, study abroad opportunities, and so on. So, if you're interested in any of these possibilities, just again, talk to your faculty. We have faculty advisors, so you can talk to them. You can talk to Casey, you can talk to me, and we can basically help you understand the whole process associated with that. Yep, next slide. Pretty proud of the support that we give to our students. And so I always want to point this out. So there are, beyond I guess you could call them the usual things that we do for students, we have some pretty extraordinary things that I point out. So we have really just a massive amount of scholarships that we give out to students, 250K plus to Chemie Math-Sci students. And so there's a process that you go through for that. Then you apply for these and that information is readily available to you, but it's just a great resource. Casey does a absolutely fantastic job of keeping you up to date on job postings and internships and co-ops and things that are going on in the department, organizing events with faculty and students. Just a phenomenal resource for the department. And so, you know, if you join the program, you'll be hearing a lot from her, and you'll be very well informed about things that are going on. The last thing I'll mention is a student-run group, Material Advantage. This is a great group of students, MSc students. It was founded quite a while ago now, 1987. And they're really just into material science, and they're dedicated to advancing the awareness of the importance of this discipline. And they want to increase student understanding of how important that is as well. So it's a really nice resource. Next slide. And finally, the people that are here for you. So there's me, there's Casey. We have SEMS faculty advisors. So if you join the program, you'll be paired up with a faculty, and that faculty member will help you pick your courses and get your plan together and talk to you about grad school or industry or whatever it is that you want to do. Really great resource. We have an undergraduate lounge where people go and they study and work together. Really nice resource. And then last but not least, we have this MSc brochure that contains all of the information I've just told you in one spot. So I've gone through this very quickly, but go there, check that out. And if you have any more questions about the program, just feel free to ask, okay? Thanks. Next slide. I think it's now Kevin. Yeah. Thanks so much, everybody.
Okay. Thank you, Professor Flanagan. A lot of the material for the chemical engineering program is the same as the material science and engineering program because it's one department. So much of what Professor Flanagan said applies here. I'm just going to focus on a few specific things related to the chemical engineering program. Next slide, please. So most people get into chemical engineering because they like math and chemistry. That was certainly the reason that I did it. And the kind of core things that people learn are analysis of chemical processes, both the science and then the engineering parts of it. And you know, I think a good way to think about what chemical engineering is relative to chemistry is that chemistry is like cooking in your kitchen, and chemical engineering is figuring out how to do the same thing, but to do it for thousands of people or millions of people. Next slide. So we also have a 4-year plan. It's a little small on the screen to see it, but the key point, there's one class in the sophomore year that's mass and energy balances. That's a kind of introduction to chemical engineering that everybody takes. And then in the spring semester of the sophomore year, we have thermodynamics as the chemical engineering class. And once those are done, you have sort of the key background. And then the junior year is largely focused on, let's say, the science of chemical engineering with one lab course that gets you into the practice of operating chemical equipment. And then the senior year is much more applied with a much larger lab class in process control and design. And then we also have, similar to Matt Sci, 12 credits of technical electives that are done over 4 classes. And a very common one that people take is polymers, which if you look in the lower right corner of the 4-year plan, this is a cross-listed class of materials, chemical engineering, and chemistry, and really one of the strengths of Minnesota's program. Next slide, please. What do chemical engineers do? Chemical engineers are responsible for changes of matter. So there's lots of different areas, and it makes sense the marriage of chemical engineering and material science, in that many chemical engineers are involved in the making of materials at large scale. Something to say less materials and more chemical engineering would be more biological application, for example, production of pharmaceuticals or food processing or biotechnology. But they're really all over the place. I think there's a tendency to view chemical engineering in the historical way that its origins came out of petrochemicals and oil refining. The number of chemical engineers employed in that industry now is quite small. I think it's, last time I looked, my memory serves me right, it was 10%. So the vast majority of chemical engineers work in other areas. Next slide, please. And so these are some of the companies that our students have been employed by in the last few years. And you see local, like 3M or General Mills. I mean, these are huge companies that are based in the Twin Cities, but the chemical engineering program in Minnesota is very well regarded, both nationally and internationally. And so we do very well in terms of recruiting all of the major companies that are in the chemical related industries. The next slide, please. Yeah, and a few examples of chemical engineers that did things that are important. The first up there is Haber and Bosch, who basically created the way to make artificial fertilizer. And my colleague Ed Kussel, who's recently retired, estimated that 2 billion people in the world, I think, are alive because of the Haber-Bosch process. So that's a good example of impact. You see a lot of examples here on the list. The last one I like is Frances Arnold. She's a chemical engineer at Caltech, won the Nobel Prize in 2018 for a way to make enzymes that'll do production of chemicals in bacteria, for example. The next slide, please. And just a few of our own alumni to toot our own horn. Phil Zietlow invented Honey Nut Cheerios and gluten-free Cheerios. Nick Halla is the first employee of Impossible Foods. If you've had the Impossible Burger, for example, that's his company. Bob Gore, who recently passed away, invented Gore-Tex, the fabric. So this is a great chemical engineering material science combination. The Gore-Tex is a waterproof but breathable fabric. That's the material science part. Making enough of it to supply the world, that's the chemical engineering part. And the last one on the right, that's Art Fry, who invented the Post-it note at 3M. Next slide, please. I have one extra slide here. I apologize for the resolution because we didn't make it ourselves. But there's a fair number of students every year who are in chemical engineering that are interested also in going to medical school. And I think it's a great preparation for medical school. This is maybe a little self-centered, but I'd like more doctors who had training in engineering and to be in the medical profession. One thing that you should know, if you're interested in a major in CSE, but ultimately going to medical school, that there is a resource called the Pre-Health Student Resource Center that will help you in making sure that you're meeting all of the criteria to go to medical school while pursuing your CSE degree. And I think that this is something, if you're thinking about it, it's better to understand what the options are, and for example, what technical electives you should consider taking so that it meets our degree plus the criterion for medical school. And so you can get in touch with them. It's the link is at the bottom of the slide. It's healthcareers.umn.edu, and they have a lot of information there for what to do if you want to major in a CSE program and also go to medical school. Next slide. Okay, so Casey, I think we'll do the introductions here for our undergraduate panel.
All right, so we have some CEMS undergraduate students that will be joining us or have joined us. Navir Sarma, the president of AICHE, Andre Bone, the president of Material Advantage, Sneha Sinha, who is, I believe, president of Engineers Without Borders, but you can correct me if I'm wrong. Vijay Valoropali, and I'm sorry about that, Vijay, who's a material science student. He was also in my CSE 1001 class a few years ago. And then Michelle Kwan, who's both chemical engineering and material science. So I will stop sharing, and if we can have the students turn on their screens. And I know Michelle was maybe going to be a little late, so but we can start if you all want to introduce yourself. So how about Vijay, if you want to go first?
Yeah, sure. My name is Vijay Valoropali. I'm a senior in material science. I don't know, I'm not particularly too in-depth in the material science student groups. I only recently joined Material Advantage, but I did join the Formula student team on campus, which works a lot with a lot of different departments. We make Formula One race cars every year, so that's kind of cool, I guess.
And you also do research, right, Vijay?
Oh, yeah, sorry. I also I do research with Professor Martignani in what I can only describe as computational physics or computational material science, one of the two. Don't really know which right now.
Sneha, do you want to go?
Sure. Hi, everyone. My name is Sneha. I'm a senior studying chemical engineering right now and also minoring in public health. And like Casey said, I am president of a student group called Engineers Without Borders. I don't know if any of you have heard of it, but a lot of engineering-based projects and partnerships with communities and organizations locally and globally. So if you have any questions about that, I'm more than happy to answer. I am also doing research, but actually in the School of Public Health, and it's more related to environmental chemistry type of stuff. So specifically to PFAS, if you've ever heard of that. And then I, this past summer, had an internship at Boston Scientific, which is a medical devices company in Minnesota. So those are kind of any questions you have around that, let me know.
Andre.
Hi, everyone. My name is Andre Bon. I am a senior in material science as well, classmates with VJ. We're suffering together. Yay. And I'm also president of Material Advantage, which is our material science club here, as Professor Flanagan stated. We just try to get a nice sense of community and some events to enrich, to give students opportunities to get their careers started and get in contact with faculty. So it's a pretty nice club, and yeah, it's a good way to feel part of this small major and be connected with everyone. As far as my personal experience, I currently do research with Professor Nate Mara in material science, and my research is focused on nanoscale mechanics of materials. So pretty much just seeing how these materials respond differently or at very like local stresses that I apply at them. And yeah, lots of interesting applications that arise from those types of testing.
All right, and if you have questions, please feel free to send them in the Q&A. And I believe the students are ready and willing to answer them. I guess I'll start off. So how did each of you decide on the major that you chose? So VJ, do you want to start?
Okay, yeah. So kind of arbitrarily in high school, I was like, oh, well, chemical engineering is cool, just out of nowhere. And so I came here. And then when I got here, I realized I liked physics a little bit more than I liked chemistry. And so I switched over to material science, and here I am.
Yeah, if I can jump on VJ's train, kind of the same boat. Really like chemistry in high school, but I also kind of like money. So I was like, chemical engineering sounds good. And when I got here, I wanted to get involved as soon as possible. I was pretty excited as a freshman, had a lot of energy still before college broke me down. And I went to several lectures. I went to a talk by my current research advisor, Professor Mara, on his research. And upon seeing that, I realized that I had a lot more interested in what he was doing. Then, so I decided to switch majors to material science. Yeah.
Yeah, echoing their answers, was really interested in chemistry in high school, but not as interested in physics. So I stuck around in chemical engineering. But definitely the problem solving aspect of engineering that's kind of involved was the part that intrigued me, and that's why I chose to go towards engineering instead of like chemistry per se. Yeah.
All right, so do you need a lot of physics in material science? Is there less physics in chemical engineering?
I wouldn't say less. I feel like the physics is applied differently. Perhaps the professors can answer this a little bit better than I can, but
Yeah.
personal opinion, they're about the same. It's just kind of like how it's used.
Yeah, a good way to break the difference is that in materials, you definitely have a lot of solid state physics, quantum mechanics. So that's not part of chemical engineering. The physical problems that you'll deal with more in chemical engineering, fluid mechanics, so that's the deformation of things which are infinitely soft, if you like, from the materials side. And and also thermodynamics. So we're not as physics heavy, but I would, if your question more refers to mathematical science, I think yes, there's like a lot of math in chemical engineering, even if it's not in traditional physics type of direction.
Yeah, if I can add, I'd say the physics and material science can be kind of split between semiconductor physics. So how are electrons moving? How does that let us use the flow of electrons to power our devices? That class is taught by Flanagan. So thanks, Flanagan, for teaching us that. And you can also have a lot of mechanical if you're interested in that. So how am I going to apply the force of this material? Is it going to fracture when I apply this force? If I apply the force bending or torsion or just compressive. So that side of physics as well. And finally, the third side would just be thermal, because thermal's everywhere. You can't kind of escape it. So.
I still don't entirely understand the main difference between chemi and mat sci. Can you explain?
Yes, probably. I think the shortest answer anybody will ever tell you is material science is things that are solid, and chemical engineering is things that are not solid. Now, that's not entirely true all the time, but the shortest answer kind of starts there, and it like expands rapidly. But of course, we work with multiple kinds of things. In material science, we have to deal with glasses as well and materials when they're not solid yet. So we still have to deal with, of course, liquids as well. And you have to make the things in chemical engineering. So it's not like they don't either, but it starts there.
And I think if you jump into the professors, if you go look at the professors in the department, lots of our professors in material science are did not study material science per se. So there's a lot of overlap. So lots of professors work with polymers. They have to deal with the polymer, like making that polymer, the synthetic chemistry, which I would say maybe falls a little more into the chemistry side. And then once they have the polymer made, they have to see how that processing that they did goes into the final product and the like mechanical properties or whatever viscoelastic properties you're interested. So I feel like in the end, you're going to be able to do the work for both sides, probably with what you learn in either major. Just a little bit, if you know what you're interested right now, you can guide yourself to learn something slightly more interested. But I believe in the end, you can probably have the knowledge necessary for both positions.
I think this is for you, Sneha. What made you choose chemical engineering over a chemistry degree?
Yeah, I was just looking at the questions and saw that one. So I think for me, chemical engineering is a lot more about like the systems thinking framework. So you're understanding processes end to end, and that's kind of how I like approaching things versus like the very finite like molecular interactions inside that side of things. And so there's a good balance of like you're zooming in really, really small, and then you're zooming out pretty big, that I've really enjoyed. And that was part of the reason that I decided to do chemical engineering as my degree as opposed to chemistry. And then, like I said, kind of like the problem solving side of things. So an engineering degree versus a chemistry degree, you're using different skills and like critical thinking skills. And when you're creating engineering designs, like the questions that you're asking are a lot more of like, I guess for me, they seem a lot more tangible in terms of how they're applied. And you're like designing a pump and piping system, for example. And that's something that comes down the line with like upper division classes. We have a unit operations lab where you get a lot of experience like handling chemical processing equipment, kind of like Professor Dorfman was talking about before. So that was my main motive with chemi. Yeah.
Thank you. And Michelle just hopped on. She just got out of lab. So thank you very much for joining us, Michelle. Are you able to introduce yourself?
Yeah, sorry about not having my video on, y'all. I am literally still in Smith, but my name is Michelle. I'm a double major in chemical engineering and material science engineering, and I'm a junior this year. So if you got any questions about the differences between each of the majors, I got you covered.
Thank you. Okay, did the U set you up well for internship opportunities?
I can hop into that. I definitely think so. I guess my internship with Boston Scientific was one that I got through the CSE Career Fair. And that was my sophomore year actually. And then with COVID, so it was planned for the summer of 2020. But then with COVID, that was canceled. And so they extended an offer again for summer of 2021. And that was my first industry type experience. It's a little like chemical engineering internships can have a wide range. You can work on a plant. For example, you can also I was working a lot on like organic chemistry synthesis, which was pretty interesting, but on the scale up side of it. And I definitely felt well prepared for the content of my internship. I used a lot more organic chemistry than I ever thought I would have, if I'm being completely honest. But it also set me up really well for like developing a relationship with the company and actually securing the internship. There are a lot of resources available in like the CSE career office. I don't quite know the name of it, but basically the folks that organize the career fair and everything, I use a lot of those resources, including like resume review, just having an outside person completely unknown to you looking over your resume and giving you feedback. All of those different, I guess, resources were super helpful as well in prepping for that, and then actually having the career fair itself and then having the internship.
Are there, excuse me, are there opportunities for specialization in either of these majors? So we don't have an emphasis or specialty, but that's where you can really use your technical electives, I would say, to kind of hone in on something. And for some students, they use that to like get a minor, like in management or computer science or chemistry. So something like that. Either of you or any of you have anything else to add with that, or did I answer it? Okay.
Yeah, I think that pretty much answered it. Like I said, I'm doing a public health minor, and that covered some of like the lower division tech electives, because overall I'm pretty interested in advancing health equity. And so that was kind of an interesting way of tackling that. But with my remaining tech electives, it's kind of been a balance of like medical devices as well as environmental remediation, and exploring those two worlds, but not having a concentration gives you kind of like the flexibility to explore what you want to. And I've really appreciated that in my 4 years.
All right. What is a class you really enjoyed, and what was a class that was very difficult?
Andre, come on, man. Come on, Andre.
I can start a difficult one and say polymers.
I was gonna say the same thing.
Polymers, as was stated before, is a class that merges both our majors and chemistry. So it's a really interesting subject. It's a very like versatile class of materials. They can exhibit so many different properties, and so much goes into it that it's really hard to cover it all in one semester. And it feels a little overwhelming because people from different backgrounds take this class. So parts of the class are much easier for chemical engineers, I believe, than for material scientists, because you're talking about synthesizing those polymers, and it's something that I'm not as familiar with. Towards the end, we covered mechanical properties, and that became much easier. So I think overall, it is a challenging course because like so much is involved in making a polymer and getting the characteristics you want. So I'd say it's the hardest class. And as far as favorite class, I'd say metals, because I love metals. They're simple. They're nice.
I think I'd actually have to say polymers is one of my favorites. And then one that isn't in the major that was hard for me was just normal organic chemistry. So definitely unpopular opinion there, but polymers was a really interesting class, despite that it was a bit difficult.
I'm gonna have to join Andre. I was not a real big fan of dealing with all the constant polymers. specifically, it is challenging because we don't typically deal with reaction chemistry, material science, and then we had to do that a lot. So that was kind of challenging. Favorite class is kind of hard to pick between. Right now, I'm really enjoying solar cells. That's a great class right there, but it's kind of hard to pick. I liked composites. That was kind of crazy. Composites is really wacky. So give that a look.
Okay, this is kind of a hard one. Because I will say I definitely think most of the classes are hard. But I think the hardest was probably like fluid mechanics, just because it's kind of a totally different way of thinking. And then as soon as you kind of like understand where things are going, it gets a little bit easier. And so that's, yeah, I think that was probably one of the hardest classes. I echo Michelle that organic chemistry was a bit of a doozy, especially jumping into it my first 2 years here. And then favorite class kind of goes along again with one of the hardest classes and is like very notorious in chemical engineering, or unit operations labs. They're essentially group projects, and you're with a group all semester and you're working on there's a lab in Amundsen where there's a bunch of different small like pilot scale chemical processing equipment. And so you're running those, getting data on those, and then using the information that you've learned in transport classes. So first off, like fluid mechanics, and then in mass transport, you can scale that up to a client specifications. And so that's essentially like exactly what you would do in an internship, which is pretty cool. An internship in your job world as a chemical engineer, that's like really relevant. And so definitely really hard because it's a shift in the way that you have to like think about things, but is interesting because of that, because you never really know the right answer and you're making justifications, and it feels very like real world-esque. But yeah, a balance for sure.
You're in it right now, right?
I am. So there's 3 phases kind of it. You have junior unit ops. Professor Dorfman was actually the main instructor when I took that. And then right now I'm in senior unit ops. And then next semester will be design, which is essentially, I think, and Professor, you can correct me if I'm wrong, but it involves like the economic analysis as well, which is also really relevant for when you're working as a chemical engineer. So.
Are there a lot of job opportunities available in these fields? I see nods, so yep.
I mean, that's what we were promised.
Yeah, I definitely came in here with that told to me. One thing I think is really, I think I tell a lot of people is there's a lot of job opportunities. There's not necessarily a ton of them at one specific company or one specific field for a lot of things, right? But for both chemical engineering and material science, literally every field out there requires at least one of us. Most of the time, one of us each. So, take that with what you will. You could work in literally anything with one of these degrees.
Yeah, particularly material science, I see is very much a jack of all trades engineering, because we're learning what inside the material makes it behave that way. Any field of engineering that relies on materials, you can be useful to it. If you want to like go into civil engineering, structural materials, if you understand like what makes a material good to support a load, that goes into it. If you want to go into electrical devices, you learn how the electrons are flowing inside. So I feel like most fields of engineering, at least from my perspective, material science, like you are able to get a job in that field if you apply yourself and if that's what you're interested in.
Pretty much everything is made of something. So, here we are.
And then
I can maybe add, Casey, before.
Yeah, thank you.
Just to give you a specific example of this. So a lot of our students go into process engineering, and I'll tell you, they don't have a problem getting jobs. That's for sure. Casey can echo that. One specific example is Intel is building a chip fab in Arizona right now, and they need to employ 3,000 process engineers. And so representatives of the company came here. That might have even just been last week, or a couple weeks ago. I don't remember. It was very recent. Came
Oh,
here
wait.
specifically. Yeah. Came here specifically telling us, how do we recruit your students? We want to hire them. How do we get them to come to Intel? So, you know, we're on the map. They know who we are, and they're very excited about the training that the students get when they go through the program. And so I think that's a nice example of how in demand the students are from both programs, Chemi and Math Sci. So I think getting jobs is not an issue. If you want to get a job and stay in the Midwest, right? I think you can even do that. That tends to get a little trickier. Sometimes you have to relocate, things like that. But I think our students are very competitive for positions when they're done. And I think the numbers show that. And, you know, having a company like Intel come here and say, hey, we want to hire as many of your students as we possibly can, I think that speaks volumes. Sorry to interrupt you there, Casey.
No, you, because the next question I was going to have you answer about the more job opportunities for Chemi or Math Sci, or is it about the same? And I would say it's about the same.
Yeah, I think they're all in high demand. I don't really remember a time when we had students having problems getting, I mean, it's always they get jobs. And I'll also say that a lot of our students are in demand for grad school. So I think the most recent numbers we had was a quarter of our class went to grad school. I mean, that's a large number. That's a lot of students going to grad school. I don't know what it is on Chemi. That's just for Math Sci, but so I think, you know, they're competitive for grad schools. They're competitive for the top places there. They're competitive for the jobs. And I think there's really no issues regardless of the program. Professor Dorfman can, I think, fill in a lot of that too.
Yeah, I think, you know, what Professor Flanagan said about jobs is I agree completely. And I've been here 16 years, and the only challenges for jobs were related to economic downturn. They were like widespread, not particular. And, you know, chemical engineering in particular tends to run counter-cyclical. So when the economy does poorly, the jobs get better. I don't understand I'm not an economist, so I can't tell you why that's the case. Other than the chemical production tends to come before products. So in order to ramp back up, yeah, you hear about the supply chain problems. That's a chemical engineering problem. Yeah, I mean, we need to make a lot more stuff so that other people can make more stuff. In terms of graduate school, the chemical engineering program is bigger. So it's typically 100, we'd like to have 126. That's the upper capacity for the lab. And I say 10 to 15% of students will go to graduate school any given year. The graduate schools they'll go to, really good. So the chemical engineering program is very widely known for the quality of the program. So if you do well in it, you can sort of just pick where you'd like to go.
All right, I was told by a different senior in CSE that as you go through CSE, it gets a little better and easier as you start your major specific classes. I wanted to hear your thoughts on this as Chemi and Math Sci students. I'm feeling quite overwhelmed with classes, but I'm only at the beginning, and I'm nervous that it will only get harder and I'll be deterred from this major.
It is a very strange balance. Michelle, go ahead.
Okay, yeah, so being overwhelmed as a freshman or a sophomore, or even right now, completely normal. We're taking classes in a really weird, not quite back to pre-COVID times situations. It's totally okay to be overwhelmed. I found that I had the hardest time, I think, sophomore and freshman year, and now it's getting a little better. I think part of it is that even if the classes do get harder, you are in classes that you love, and you know that you're doing this for the job or for the career that you hope to have. So it's that type of motivation and the camaraderie you can build with all the other people in your major that make it easier as you get further into your education. So even if the classes do seem harder, you're with people you like and you're doing what you love. So it's worth it.
Yeah, I echo Michelle's words. Conceptually, they get harder because you're learning more advanced things, more that apply more to the real world. So they do get harder, but you start building your background. So things they are hard in fact, but they seem easier because you know what you need to know to understand it. So I won't worry about it too much. And the camaraderie is just there to save you. I would not have survived junior year without my colleagues like helping me out. And like I particularly did good in my metals class because I enjoyed it a lot. I did not do so good in polymers, and I had friends that are really good, and they helped me understand those concepts. So I feel like because we're in a more closed space of people that like are studying the same thing and know the same issues you're having, it gets a lot easier because you help each other, and like the major supports that. And most professors say, go study with your friends, like go like, yeah, try getting help on these. You're not expected to go at it alone. And I think that helps a lot.
All right. Are the upper division labs for chemi difficult?
No.
Okay. We'll leave it at that.
There you
no.
go. No, they're not
They're
difficult.
not. No. I think the reason that they're difficult is because yes, they are. They're definitely challenging. At least they have been personally for me, but I think a lot of that has been because like you have to shift your mindset a little bit from what you're usually doing in school. And in classes is like you're given equations, or you figure out equations and you know what you need to answer, and you know that there's a right answer. With these labs, there is no right answer, and getting used to that is pretty uncomfortable. And you're also like, each lab has a different facet to it that pulls from something that you've learned. So you're also kind of relearning that in a way that's more applicable to the real world. And that whole process, I think, is challenging. And what's challenging too is because you're doing that each time about a different topic. But at the same time, it's very relevant and is a really useful skill to have. I know it was really, like, I think one of my biggest takeaways has been like how to ask questions in a way that I will get answers, and will get answers that will help me think more. That's kind of like the whole principle of it, is always just figuring out how to think about all of these different components when you're working on this design, because that's the goal as an engineer. And it was super useful too when I had my internship, for example, this summer, being able to kind of frame things in that way and take that approach towards things. So the answer is yes, but for good reason.
Yeah, I'll tell you why I said no. It's not that it's like, I didn't want to say it's easy, but there are other things in science and engineering that are much harder, like polymer class. Okay, that, you know, there are the purpose of the laboratory class is to give you a chance to become a professional or something approaching a professional engineer in an environment in which you can fail at it and it's not the big deal, right? So we put you in, I think uncomfortable is a good choice of words, right? It is uncomfortable because we tell the students, go in the lab and try to figure out how this thing works and get some data off of it without a lot of detail about exactly how to do it. It's not a cookie cutter kind of lab, but you need to learn how to do that. And you know, we do it in a way that tries by repetition to try to get you in a way that to have exactly the skills that Sneha mentioned. And I think ultimately we're pretty successful by the time people finish the second lab course, that they've acquired many of those skills. Whether they felt very comfortable in the course of doing that is a totally different issue. But I can tell you one thing: you want to learn those things in school. You don't want to learn them on your first job, where you show up and you've never done any of those things. You absolutely want to be prepared this way. And since I've been here, we moved the junior lab. What's now the junior lab used to be in the senior year, and the whole reason to pull it back was to prepare people for internship. So when they show up for an internship, that they're in good shape. And so we hear frequently from people when they start their job how much better prepared they felt they were than their peers, and that class is a big part of the preparation.
All right, this one was voted up, so we will answer it now. If you worked in research, did it help with classes and labs?
Go, Vijay.
I may or may not have been the one to vote that up. So,
Okay.
Sorry, you can go first, there.
Okay, I guess I can go first. I mean, not exactly, but it sort of depends on what your research is in, and also what your classes are at the time. Like, you may not start research immediately upon becoming, into the major as a freshman or a sophomore even. I started research literally this semester, so kind of went through a lot of the classes beforehand, but it kind of goes back and forth. Like, My research is very computational, and so my numerical methods class helps with that. If I was doing research into something I was studying right now, I know for a fact it would help me because now I suddenly understand a lot more about computational material science. So it sort of depends on the time, the class, the research, all kinds of business. But I mean, yeah, sometimes.
Yeah, so I had a bit of the opposite situation where I got into research early, and that meant that I do research in polymers and a lot of the like mechanical rheological properties there. So polymers class was nice for me because it applied to my research. And then currently I'm in transport phenomena, which uses some aspects of my research that I'm used to seeing. So having a little bit more background or some tangible, like, oh, this looks exactly like what I did in the lab last week helps a lot in terms of focusing down and giving you more intuition to how to solve the problems.
All right, do you feel like your major required a lot more work compared to your peers in other CSE fields?
Definitely not. I on the formula team, I constantly, like literally constantly work with people across the engineering fields. All of my coworkers are basically mechanical engineers, electrical engineers, computer scientists, like aero engineers, like everybody. And I don't think it's really safe to say that we have it much harder or much easier in any way. It's just kind of like what you enjoy doing. So I know for a fact, if I tried to take all these aero classes, I would have a really hard time because I'm not a really big fan of that kind of work. But I also found the material science classes a lot easier. When they found their material science class, they have to take much harder. So I wouldn't really say it's much harder. Everybody has their own really challenging workload that they do. But if it happens that you're really interested in it, you'll find it's a lot easier than what other people would tell you it is.
All right, well,
Yeah,
BJ, sorry, go.
No, it's okay. I was just going to echo that in Engineers Without Borders, we definitely have a wide variety of different engineering major backgrounds that are involved. So a lot of civil engineers, as well as like bioproducts and biosystems are our main two, as well as mechanical. And I think the workload is pretty comparable across CSE in terms of, especially like as you get towards upper division classes, kind of that shift of like going from general to something that's more focused, and what that looks like across that any major. So I was just going to echo what BJ said.
Thank you. All right, VJ, what did you learn in the solar cells class?
Well, currently taking it, but we already learned or reviewed a lot of the electrical properties in semiconductor physics of PN junctions. We also spent a lot of time learning about the energy landscape of like the whole world in terms of consumption, production, use, wear, time, like everything. Like you start from the beginning and go to the end. So what we're going to do will be a big focus on silicon-based solar cells, and then cadmium telluride solar cells, and then other solar cells after that. But it's some real cool stuff. You learn a lot of things you didn't think you would learn, and you learn a lot of things that are just sort of mind-boggling, like how much energy the world uses. It's kind of crazy. If you want to see something cool, look up what a quad is. Great unit of energy. Don't know why they called it that, other than I guess it's a quadrillion somethings. But it's a lot. I mean, US uses 100 quads, I think, this year, right, Andre? Yeah.
Yep.
100 quads of energy. That's a lot of energy. But yeah, so you learn some cool stuff.
It's a really good class. It's a tech elective, so if this is not your style, don't worry about it. Don't have to take it. But I highly recommend it. It's a new tech elective, so the professor's like improving every year, still working on it, and yeah, no complaints about that one. It's really interesting stuff.
What student organizations or clubs would you recommend joining if you are interested in meeting other students in engineering majors as well as building your resume?
I have to say material advantage because material advantage. But we're in reality we're pretty material science focused. We're open to everyone, but we usually get more material science. But yeah, I know Sneha's club is really good, and I particularly have get involved in Tesla Works in the past as well. Definitely go to the CSE student club events. There's a lot of interesting stuff happening for whatever you like doing.
I'm gonna go ahead and plug the Formula team. I've joined a few student groups over the years, stayed in some, joined some new ones, left some other ones, but Formula is the only one I've stayed in all 4 years, and you will literally do anything you want, and you will work with every major. And I can't imagine a better resume builder than we build a car every year from the ground up, from scratch. So, I mean, like, what better can you do?
Yeah, I definitely think it would be based on what your kind of goal is in joining a student group or a CSE group. So like ones like Formula, for example, or even Engineers Without Borders are pretty project oriented, which is kind of cool because you get to, especially like when you're in lower division, so your first or second year, you're not really using a lot of like your engineering skills yet, or not really developing those, but joining one of those clubs gives you a way of doing that. And it's kind of like the best group project you could be in, if that makes sense, because everyone that's there wants to be there and wants to work on those things. So for Engineers Without Borders, which I will plug for a minute, we do a lot of like water distribution systems. And so we partner with communities internationally in designing and implementing those. We're partnering with communities in Ethiopia and Guatemala. And then also we've taken on kind of a local focus in these past few years, especially with COVID, and focusing more on like sustainability related projects. So this past year, for example, we just wrapped up a partnership with a local community garden in St. Paul, and they're designed a rainwater catchment system where fluid mechanics came in handy. We designed greenhouse we installed solar panels and designed that, as well as like the pavers that we put throughout the entire garden. So those are definitely more project focused, but then there are a lot of other CSE student orgs that are more like community and outreach focused, which is also really fun. And so like ones like Materials Advantage and American Institute of Chemical Engineers are a really good way of like meeting people in your major, as well as organizations like, I know that there's SAFE, there's NESB, that are more related on community building. So there's a lot, I think, and I think CSE does a good job of kind of covering all the whole field when it comes to it.
All right, I'm going to try to answer this last question, and because it's also been voted up. So is coding very prevalent in CEMS?
As far as classes go, not necessarily. At least in material science, you only have one class that is coding heavy. But if that's something you're interested in and you want experiences in research, in the field is something definitely can focus on. Lots of professors do computational material science, computational chemical engineering. So it is as much as you want it to be, essentially. You can use your tech electives to learn more about it, but the core classes, you're going to learn the basics, not much more than that.
I think one thing you'll find when taking your classes is there's a lot of differential equations, as in all of engineering. And a lot of these can genuinely only be solved with, coding. That doesn't mean you have to do it all the time by any means. You definitely don't. But you will see how useful of a skill it will end up being. And so, you may not have to do it constantly, but you will constantly have it like shown to you like, oh, here's a problem. It's only computationally solvable. So look to the future.
All right, there's one more question that's been voted up. I know it's always important to get the best grades you can, but what if you carry grades closer to the lower end of the grade spectrum, not necessarily failing, but lots of C's? Is that okay as a CSE student?
I think whatever grade you can get in a class is okay, because especially if it's your best work, not everyone's going to get an A in all of our classes. And I think you shouldn't be defining your worth based on whatever grade you get in classes. So I've got some classes where I've got like B- or C's, and that's completely fine, especially making sure that you give yourself some grace in that we're in a weird situation. You're taking classes in, and try not to get too down about whatever grade you do end up getting. Remember, you might still have pass-fail options. So if there's something going on this semester, or you can talk to professor and see if you can get some type of accommodation if you're going through something on a personal level, try and help with your grades. And if your grades aren't that great, but you're looking for a grad school or going into industry, you can try and bolster with extracurriculars to demonstrate that you know how to like build a car if you're doing formal SAE, or you do a lot of community outreach, and those will help boost whatever resume and make you a little bit more well-rounded if you're worried your grades are a weaker point.
Yeah. I think what you'll find is later on, maybe a year after graduation, maybe not graduation, jobs you apply to will not really care if you got a C in calculus or you didn't do the best in organic chemistry, because they only really care that you've learned and you've gotten these skills along the way. So student groups are a great way to get that experience, but being in your classes, even if you don't do the best on tests, like, you've learned those things, and those things that you've learned are what you're really using. You're not using your report card to, do your engineering work in the real world.
Okay, I want to be mindful of time because it is after 5. And I am guessing a lot of our attendees might be ready to go eat or something like that. There's a couple of questions left, and I said in the chat, if you can email me and I will route it to one of the students or to Professor Dorfman or Professor Flanagan. But thank you all very much for coming. I am a little floored by the number of attendees we had. So thank you for coming. And like I said, if you have questions, please feel free to email me, kgregors@umn.edu.
Thanks, everybody.
Thank you for coming.